Imagine you are floating among the stars. There is no sound, only the deep silence of the universe. But suddenly, a distant point in the darkness flickers, a sign of a world billions of light years away from us. What lies there? Is this the ultimate limit of our sight, or just the beginning of an unknown adventure? We are about to take you on a journey to the farthest known points of the universe, where light has traveled for billions of years, and it will lead us to the beginning of the universe. What did we actually see in the very first moments of the universe? We are moving at an incredible speed, traveling back in time. We are still moving forward until the moment when the first galaxies begin to shine. In the distance, a faint and distant light appears. That's it. GNZ 11, one of the first galaxies ever formed in the universe. It doesn't look like the galaxies we know. Here, there are no spiral arms, nor any organized structures. The GNZ 11 galaxy is a chaotic mass of gas and young stars, rapidly growing and evolving. This galaxy is about 25 times smaller than the Milky Way, and only 1% of the mass of our galaxy. Here, wherever we look, we see stars that are just being born from the depths of gas clouds, a luminous display of the formation of the first generation of stars in the universe. This galaxy formed during a time when the universe was just emerging from darkness. The massive stars here are ionizing the space with their intense light and energy, literally pulling the universe out of its initial foggy state. For scientists, GNZ 11 is a living proof of the early universe, a clue to understanding how galaxies formed and how they have evolved over time. Given that this galaxy is 13.4 billion light-years away from us, the light traveling from it has been on its way for 13.4 billion years to reach us here on Earth. So, in reality, we are looking into the past of these celestial bodies, and right now this galaxy has probably changed shape or merged with another galaxy. Come out of there and once again find ourselves in the dark space, where a light is visible in the distance. We get closer and closer, and there, it's filled with massive, high-mass stars that are breaking the darkness of the universe with their light. These stars will explode very soon, creating the next generation of heavier elements, those very elements that will later form the basis of planets and even life. We reach an extraordinary destination, Jade's GSZ 14-0, one of the farthest galaxies ever observed. Here, we are at a time approximately 290 million years after the Big Bang, when the universe was still very young and dark. Its light has been traveling for more than 13.5 billion years to reach us, bringing it very close to the Big Bang. Even if it still exists today, its actual distance is now more than 33 billion light-years. Do you think why? Imagine the universe as a balloon being inflated. If we consider the points on the surface of the balloon, as the balloon inflates, the distance between each point and the others increases, without the points themselves getting smaller. In the same way, galaxies are moving apart, not because they are moving through space, but because of the expansion of space itself, which has continued since the Big Bang. One of the important effects of the universe's expansion is that the light from galaxies is being stretched. This phenomenon, called redshift, means that the wavelength of light emitted from a galaxy with greater distance is stretched and shifted toward the red end of the light spectrum. This effect helps us better understand the distance between galaxies and the history of the universe. Let's move further away from here and head toward a very ancient black hole. If you don't know what black holes are, let me give you a brief explanation about them. Black holes are extremely dense objects with a very strong gravitational pull from which nothing, not even light, can escape. They form when a very massive star collapses at the end of its life, or through galaxy mergers and gradual accumulation of matter. Now, we have managed to see one of the most distant black holes, COS 87259. This black hole is located approximately 13 billion light-years away from us. Its mass is several hundred million times that of our Sun, and it has grown incredibly fast. While other supermassive black holes take a long time to reach such a size, this one became enormous in a very short period. This black hole falls into the category of rare and mysterious quasars, surrounded by a dense, gaseous halo and emitting intense radio waves. It was likely formed through the direct collapse of a massive gas cloud. Let's move away from there and, this time, head toward one of the oldest known planets in the universe. We reach the heart of a very old star cluster, where the Methuselah. This planet is very old and was one of the first planets to form in the universe. The age of this planet is 12.7 billion years. That means it's nearly 3 times older than Earth and formed just 1 billion years after the Big Bang. And it's about 12,400 light-years away from us. So, what made it live for so long? The Methuselah planet has had a long lifespan because it orbits an ancient star and was formed under unique chemical conditions during the early universe. This planet is made of primordial materials that date back to the early times of the universe, and its long lifespan might be due to orbital stability and the lack of significant changes affecting it. This planet orbits a neutron star and a white dwarf, which is a rare configuration. A neutron star is the remnant of a star that forms after a supernova explosion. This star is extremely dense, and its density is such that a teaspoon of it weighs several billion tons. A white dwarf is the remnant of a star that becomes this way after exhausting its nuclear fuel and undergoing various processes. This star has a high density, but it's less dense than a neutron star. Now, this dead and frozen world lies next to the white dwarf and neutron star, and the deadly radiation, low temperatures, and lack of atmosphere make it incredibly frightening. Let's move a bit further from here. We reach the star Arundel. It is about 13 billion light-years away and is likely 50 times the mass of the Sun and thousands of times brighter than it. This star likely exploded a long time ago, and it no longer exists. We are only seeing the light from its past, the light from a journey that traveled billions of years across the universe to reach us. But let's reach our final destination. Beyond the distant galaxies where the boundaries of our horizons lie, and beyond that, there is nothing left to observe. The cosmic microwave background.